Hi, my name is Munir Hassan. I work for Amazon Web Services as a prototype architect. I'm here today to talk to you about a project I worked with a company called SolShare, enabling sharing of solar energy through a microgrid in a peer-to-peer network in Bangladesh. During this presentation, I'll give a glimpse at the work that SolShare does, the need for AWS IoT, a look into the Amazon FreeRTOS, and finally, thoughts on the future. Before we start, I thought I'd take a moment to share with you a personal story. It's 1988. I'm 5 years old, and I'm visiting my grandfather in Dhaka, Bangladesh. We're chatting away and just spending the evening. Suddenly, nothing. The lights have gone out. The power has been cut. The unfortunate thing is, this often occurs. It's just the way things are. I often think back to that, and I'm glad to say things have changed. And one of the companies that's made that possible is SolShare. SolShare allows solar panels to be connected to batteries, but more importantly, it allows the interconnection from one home to another, so that excess energy that is captured by those solar panels can be shared within a community. Even if the household doesn't have a solar panel, they can actually connect onto the network and trade electricity from those that are able to have those solar panels. Now I'd like to share with you a look at the work that SolShare has done.
গ্রামের নাম হচ্ছে চরবেলামারি বন্দারচর এখানে ওরা কোম্পানি থেকে বিদ্যুৎ দিচ্ছে
So we surveyed this site about 2 months ago. Part of the survey we looked at the distance between the houses and the size of the solar home systems. Most of the solar home systems in this village are pretty large. They are all above 80 watt peak. There's only one system that's about 65 watt peak. So the major challenge in the whole process is usually community engagement. A couple of days ago, we actually came here and dedicatedly interacted with each household to explain to them how this whole system can benefit them and how they can sell their power and buy more power to run more loads.
যাতে বাড়তি কারেন্টটা থাকলে এটা বিক্রি করার জন্য আয় হওয়ার জন্য
বাতি দিয়ে অনেক কিছুতে করা যায় লেখাপড়ার সুযোগ হয় খাওয়া দাওয়ার সুযোগ হয়
আমরা SolShare যে সোল বক্সগুলো লাগানো হচ্ছে এবং যে শেয়ারিংটা হচ্ছে সেই শেয়ারের ফলে যাদের অতিরিক্ত এক্সেস বিদ্যুৎ থেকে যাবে সেই বিদ্যুৎগুলো তারা বিক্রি করতে পারবে এর ফলে তারা আর্থিকভাবে লাভবান হবে এবং কি যখন দেখা গেল তাদের ঘাটতি হয়ে গেছে তখন অন্যের কাছ থেকে তারা কিনতে পারতেছে
Today the first step for us is to make sure everybody's on board and then start laying out like where a cable's going to go, who's going to be connected to whom. It doesn't really matter in terms of where the energy is flowing because it's a big common pool, but it makes sense from a cost perspective to not take the longest route between two houses. Then the second layer for the smart nanogrid is ICT, exactly. So as we enable mobile money, as we enable smart metering, we need to be able to communicate with our boxes, and we do that over a Wi-Fi connection so that all of our boxes are connected to the internet. One big step for us is to start a local Wi-Fi that then is spread through the houses, and that's always also an important second step.
So at this stage, we are almost done with the interconnections between the households. Once we have checked that, then we start plugging in the solar home systems into the solar boxes so that the system comes live. Once it's live, then we just check whether the data is being relayed back into our system and whether we can monitor it remotely. And once that's done, I think we're good to go.
All right, and you'll see the lights go on.
Very soon.
And this is the device. This is what makes the difference. This device connects to the battery that is connected to the solar panel and is able to measure the amount of energy that has been captured. Any of the excess energy is then connected to the network so that the energy can be traded and others can then purchase it for their needs. Inside this device is an ESP32. It allows the connection from the measurement to AWS IoT. So why is AWS IoT part of the story? Well, we need to understand how much energy has been collected. Is there an excess? And the ability to be able to share that information for the home user on their mobile phone. With AWS, we have an AWS IoT service. It allows an endpoint to connect to. Once a constrained device is connected, it's able to send an MQTT message. The message allows data to reside in the cloud so we can look for trends and provide some analysis. And more importantly, find out what the excess capacity is for a home. This is what the MQTT message looks like. It's a simple topic and payload. In this case, the topic would be the actual device, the village, the actual home itself, and the payload would be the information about the amount of energy and the time in which it was measured. MQTT essentially uses a publish and subscribe model. So when the device is ready, it will publish, and something like a mobile phone is able to subscribe to that message and see what the energy reading is. I've talked a lot about the device and the cloud, but in order for the device to connect, there is a small operating system running inside the microcontroller, and that's running Amazon FreeRTOS. It's a very small OS that is designed for low-power microcontrollers. It provides the libraries for the connectivity and security needed to connect to the cloud. More importantly, by providing this OS, it makes it easier for the developers to write the code. Otherwise, they would have to do what is called bare metal code. They would have to write every single type of event as well as sequence it. To explain this a little further, let me go into a bit more depth. In the case of SolShare, there are 4 tasks that need to run on the microcontroller. One is to measure the amount of energy that's been captured. The second is to display it on the LCD. The third is to connect to the Wi-Fi. And the fourth is to send that MQTT message. Now, in the ideal scenario, things would happen in sequence. First, you do task 1 of measuring the amount of energy, then task 2, which is display it, task 3, connect to the Wi-Fi, and finally task 4. But in reality, in the real world in particular, certain things will happen that interrupt that sequence. So it might be a case that we've measured the electricity, we're displaying it, but we may want to measure it again and then display it again in the time that it was trying to connect to Wi-Fi. By having an operating system, it's able to prioritize the tasks that are important and then get back to the task that was at hand. And this is possible because the OS has a scheduler. So if a task is ready, it'll run. But if a higher task, say for example, the user wants to see the energy collected, the current running task of connecting to the Wi-Fi can be suspended, and the microcontroller can then run the task of displaying the data on the LCD. Once that's done, it can go back to connecting to Wi-Fi. So it can go from a suspend state back to a run state. There might be cases whereby you may want to measure the actual energy that's been collected, but the data is not there. So in that case, the task could be blocked. Once the data is available, it can then be in a ready state to then run. And that's what this state machine essentially shows. This is what the scheduler is able to do and handle. This simplifies the task of writing the code for the developers. No longer are you having to write interrupt routines in order to handle such a sequence of events, but you're able to focus on what matters to you and provide the priority. So for the developer, they write a task, and the task has a pointer to the function, gives it a name, provides a certain amount of memory that needs to be allocated for that task to run, and then provides a priority. And as you can see, this is an example of the MQTT message task. And you can see there the simple act of providing the functionality to give the message that needs to be in the MQTT packet. By simplifying the code, it means the developer can rest assured that the operating system can handle any sequence of events. Therefore, once it is programmed, it is able to send that IoT data to AWS IoT for further use. And that's the solution. Have the device, use Amazon FreeRTOS as a simple OS, create your tasks that matter, connect, and send the data. And as a result, 116 villages in Bangladesh are now able to be sustainable and self-reliant on the solar energy within that community. With over 2,000 devices, we've been able to make an impact on over 55,000 people's lives. This is a quote from the CTO of SolShare, and I'd like to highlight a particular point. They've been able to shift their development resources to focus on building that innovative peer-to-peer microgrid. And I think that's the key point. Technology is great. It should enable an impact, and it's about focusing on the application so that it makes people's lives easier. I believe with Amazon Web Services and Amazon FreeRTOS, it's made that difference, and we're very happy with the impact that it's made to the lives of the people in Bangladesh. Thank you for your time. I hope you've enjoyed this presentation.